क्वालिटी कंट्रोल इन क्लिनिकल लेबोरेटरी चैप्टर 11 ऑफ बायोकेमिस्ट्री। आज हम लोग क्वालिटी कंट्रोल देखेंगे। चलिए शुरू करते हैं। क्लिनिकल लेबोरेटरीज हेल्प इन द डायग्नोसिस ऑफ डिजीजेस। इन करेक्ट रिपोर्ट issued by any laboratory will lead to misdiagnosis and inappropriate treatment with disastrous consequences. Although laboratories try to perform tests with utmost care, still results issued by various laboratories on any parameter of the same sample of blood varies very widely between laboratories, ranging from low to high values, as has been demonstrated by many external quality control surveys. Thus, it is necessary that the analyst should be aware of the necessity to introduce quality control measures. Errors in laboratory results may be due to mistakes in pre-analytical, analytical, or post-analytical procedures. Only a few examples of each type will be given here to elucidate the point. Example of pre-analytical error are wrong labeling of patient sample, collection of blood for sugar estimated in tubes without fluoride, blood collection for electrolyte in tubes contaminated with electrolyte, collection of blood for certain hormones analysis without choosing the right time, etc. Measurement of sample and reagents by inaccurate instruments, unclean glasswares, unchecked measuring instruments such as photometer and balances. Poor quality of distilled water, deteriorated reagents and standards, etc. are examples of analytical errors. Error in calculation, mistakes in transcription of results are report form and delivery of report to wrong patient, etc. are examples of post-analytical error. Some of the errors are random. Some of the errors are random and creep in due to inattention. Some of the errors are random and creep in due to inattention. They are called random error, such as forgetting to put a reagent in the reaction tube or writing wrong name on sample label. रैंडम एरर क्या होता है? तो सम ऑफ द एरर आर रैंडम एंड क्रीप इन ड्यू टू इनअटेंशन। कभी कभी ध्यान नहीं रहता उसके कारण, जैसे कि दे आर कॉल्ड रैंडम एरर्स सच एज फॉरगॉटन टू पुट योर रिएजेंट इन द रिएक्शन ट्यूब or writing wrong name on sample label. Such errors can be avoided by giving close attention to work but there are errors which are due to deteriorating reagents, incorrect standard solutions, deteriorating instrument, non-calibrated measuring instrument, poor analytical methods, etc. These cause systemic error. Okay, once again, some of the errors are random and creep in due to inattention. They are called random errors, such as forgetting to put a reagent in the reaction tube or writing wrong name on sample label. Such errors can be avoided by giving close attention to work, but there are errors which are due to deteriorating reagents, incorrect standard solutions, deteriorating instrument, non-calibrated measuring instruments, poor analytical methods, etc. These cause systemic error. With the ever increasing number of new tests being introduced, we as laboratory in charge have to satisfy ourselves that the results we are giving is accurate and reliable. With the ever increasing number of new tests being introduced, we as laboratory in charge have to satisfy ourselves that the results we are giving is accurate and reliable. To understand what quality and reliable results mean, let us try to understand a few terminologies that is commonly used worldwide. Okay. Statistical measurements of accuracy and precision reveal a test's basic reliability. These terms, which describe sources of variabilities, are not interchangeable. A test method can be precise, reliably reproducible in what it measures, without being accurate, actually measuring what it is supposed to measure, or वाइस वर्सा. क्या कहना चाह रहे हैं यहाँ पे? स्टैटिस्टिकल मेजरमेंट ऑफ एक्यूरेसी एंड प्रिसीजन रिवील या टेस्ट बेसिक रिलेबिलिटी. These terms, which describe source of variability, are not interchangeable. A test method can be precise, reliably reproducible in what it measures, without being accurate, actually measuring what it is supposed to measure, or vice versa. Okay, accuracy. A test method is said to be accurate when it measures what it is supposed to measure. This means it is able to measure the true amount or concentration of a substance in a sample. Picture a bull's eye target with a arrow correctly hitting the center ring, and you see what an accurate test produces. The method is capable of hitting the intended target. Precision. A test method is said to be precise when repeated determinations, analyses on the same sample give similar results. When a test method is precise, the amount of random variations is small. The test method can be trusted because results are reliably reproduced time after time. Picture a bull's eye target with arrow all clustered together, but not in the center ring, and you see what a precise but inaccurate method produces. The method can be counted on to reach the same target over and over again, but the target may not be the one intended. When the method is both precise and accurate, bullseye. Although a test that is 100% accurate and 100% precise is the ideal, in reality this is impossible. Although a test that is 100% accurate and 100% precise is the ideal, in reality this is impossible. Tests, instruments, and laboratory personnel each introduce a small amount of variability. This amount of variability does not usually detract from the test values, as it is taken into account. A specificity measures a test's ability to correctly generate a negative results for people who don't have the condition that's being tested for, also known as the true negative rate. A high specificity test will correctly rule out almost everyone who does not have the disease and won't generate many false positive results. Example: a test with 90% specificity will correctly return a negative result for 90% of people who don't have the disease, but will return a positive result, a false positive, for 10% of the people who don't have the disease and should have tested negative. Once again, a specificity measures a test's ability to correctly generate a negative result for people who don't have the condition that's being tested for, also known as true negative rate. A high specificity test will correctly rule out almost everyone who does not have the disease and would not generate many false positive results. Example: a test with 90% specificity will correctly return a negative result for 90% of people who don't have the disease, but will return a positive result, a false positive, for 10% of the people who don't have the disease and should have tested negative. ये हो गया स्पेसिफिसिटी। ये क्या बोल रहा है एग्जाम्पल में कि एक टेस्ट किया, ठीक है, या टेस्ट विथ 90% स्पेसिफिसिटी विल करेक्टली रिटर्न या नेगेटिव रिजल्ट फॉर 90% ऑफ द पीपल हु डोंट हैव द डिजीज। यानी जिसको बीमारी नहीं है उसको नेगेटिव दिया 90%, लेकिन 10% को क्या कर दिया पॉजिटिव, जिसको बीमारी नहीं था उसको पॉजिटिव कर दिया, है ना। यही बोल रहा है बट विल रिटर्न या पॉजिटिव रिजल्ट या फॉल्स पॉजिटिव फॉर 10% ऑफ द पीपल हु डोंट हैव द डिजीज एंड शुड हैव टेस्टेड नेगेटिव। ओके, सेंसिटिविटी क्या होता है? सेंसिटिविटी मेजरेस हाउ ऑफन या टेस्ट करेक्टली जनरेट्स या पॉजिटिव रिजल्ट फॉर पीपल हु हैव द कंडीशंस। सेंसिटिविटी measures how often your test correctly generates a positive result for people who have the condition that's being tested for, also known as the true positive rate. A test that's highly sensitive will flag almost everyone who have the disease and not generate many false negative results. Example: a test with 90% sensitivity will correctly return a positive result in 90% of people who have the disease, but will return a negative result, a false negative, for 10% of the people who have the disease and should have tested positive. To demystify the various terminology, let us look at the example of a test that is done to detect pregnancy in women. To demystify the various terminologies, let us look at the example of a test that is done to detect pregnancy in women. How sensitive is the test? As is how many actually pregnant women does it correctly identify as pregnant? How specific is the test? How specific is the test, as in how many not pregnant women does it correctly confirm as not pregnant? What is the false negative rate, as in how many women who were pregnant were told they are not? What is the false positive rate, as is how many women who were not actually pregnant were told they were pregnant? Approach to quality assurance. In a clinical laboratory where hundreds of investigations are done every day, there is a need to minimize the error, if not produce complete error-free results. For achieving this, the laboratory staff has to employ quality checks. For this, various measures are employed. One such measure is called quality control procedures, which can be divided into internal quality control procedure and external quality control procedure. For internal quality control, a control sample whose constituents concentrations are known is run as a known sample in all batches of analysis. If the value of a constituent which is being measured in the control sample falls within 2 standard deviations of the mean value assigned to the control, the result of that batch is considered good. Okay, once again, for internal quality control क्या कर सकते हैं, या control sample whose constituents concentrations are known is run as unknown sample in all batches of analysis. If the value of a constituent which is being measured in the control sample falls within 2 standard deviations of the mean value assigned to the control, the result of the batch is considered good. Otherwise, the whole batch is repeated again after attending to the cause of the error. Such a control sample is either prepared by the laboratory itself or can be purchased from in this way. Precision in measurement is assured. Okay. Such a control sample is either prepared by the laboratory itself or can be purchased from commercial source. In this way, precision in measurement is assured. However, such result may not be accurate. For achieving accuracy, laboratories use calibrator from commercial sources whose assigned values are retraceable to internationally approved techniques. Each day, the assay procedure is calibrated by using the calibrator. दूसरा है एक्सटर्नल क्वालिटी कंट्रोल प्रोग्राम्स is run by an external organization such as professional societies or by companies. In this scheme, the same sample is distributed amongst all participating laboratories for analysis. The laboratories analyze that sample for various constituents and reports. The laboratories analyze that sample for various constituents and reports back to the organization distributing the sample. The organizing center collects all results and after excluding those results which varies widely calculates the mean of results and its standard deviation and reports back to the laboratories showing how well a particular laboratory has performed and how close it is to the correct and conscientious value. If the laboratory's results differ by more than 2 standard deviation, the laboratory has to improve its performance by correcting its deficiencies. In this way, the acceptability of results of a laboratory becomes universal. In this way, the acceptability of results of a laboratory becomes universal. Such assessment is done at regular intervals. A result of any analysis which is done to the consensus values of the group as denoted by a small standard deviation is considered good and acceptable. A result of any analysis which is closer to consensus value of the group as denoted by a small standard deviation is considered good and acceptable. Statistical methods. There are several statistical methods in use which help monitor the quality of the tests on daily or on a periodic basis. One such simple way of keeping track of our results is to use the Levy-Jennings chart of individual tests. Some of the statistical methods used before we can use the LJ chart are the mean and standard deviation. Some of the statistical methods used before we can use the LJ chart are the mean and standard deviation. Mean. The mean or average is the laboratory based estimates of the analyte's true value for a specific level of control being used for calculating. Therefore, to calculate the mean of a particular control, we first add all the values collected for that control and then divide the sum of these values by the total number of values. मीन का मतलब समझ के द मीन और एवरेज इज द लेबोरेटरी टेस्ट एस्टिमेटेड ऑफ द एनालाइट्स ट्रू वैल्यू ऑफ या for a specific level of control being used for calculating. Therefore, to calculate the mean of a particular control, we first add all the values collected for that control and then divide the sum of these values by the total number of values. For example, to calculate the mean for the normal control for potassium, we have the following results of potassium is equal to 4.0, 4.1, 4.0, 4.2, 4.1, 4.1, 4.2. We add all the values, that is 28.7 millimole per liter. The number of values is 7, n is equal to 7. Therefore, the mean for the normal potassium control is 4.1 millimole per liter or 28.7 millimole per liter divided by 7. Standard deviation SD. Standard deviation is calculated for the same parameter for which we use to calculate the mean. SD provides the laboratory an estimate of test consistency at a specific concentration. Many a time the term precision is often used interchangeably with a standard deviation. A standard deviation helps us quantify how close numerical values our results are in relation to each other. Good precision is especially needed for tests that are repeated regularly on the same patient to track treatment or disease progress. For example, a diabetic patient in a critical care situation may have glucose level run every 2 to 4 hours. In this case, it is important for the glucose test to precise because lack of precision can cause loss of test reliability. If there is a lot of variability in the test performance, high impression, high standard deviation, the glucose results at different times may not be true, leading to the physician giving the wrong treatment. Figure 48. Example of good precision and accuracy. Example of poor precision, high imprecision. Calculation of standard deviation for a set of quality control values. S is equal to root under sigma xn minus x dash आणि मीन का होल स्क्वायर upon n minus 1, where s is equal to standard deviation, x dash is equal to mean average of the QC values, sigma x minus x dash square, the sum of the square of difference between individual quality control values and the mean, n is equal to number of values in the data set. To calculate the standard deviation for the normal level of control, begin by calculating the mean. Preparing a Levy-Jennings chart. A standard deviation is commonly used for preparing Levy-Jennings algebra chart. The Levy-Jennings chart is used to graph successive run-to-run or day-to-day quality control values. A chart is created each test and level of control. The first step is to calculate decision limits. These limits are plus minus 1 second, plus minus 2 second, plus minus 3 second for the mean. The mean for potassium control that we calculated earlier is 4.1 millimole per liter, and the standard deviation is 0.082. The formula below provides example on how plus minus 1 second, 2 seconds, 3 seconds quality control limits are calculated. These ranges are used with the mean to construct the Levy-Jennings chart as shown below. Plus minus 1 second range is 4.0 to 4.2 millimole per liter. (4.1) minus 0.1 is equal to 4.0. 4.1 plus 0.2 is equal to 4.2. Plus minus 3 range minus किया तो 3.8 plus किया तो 4.4. These two data we can then plot algebra chart for potassium for the control level that we are testing. The above chart tells the lab in charge that the potassium analysis that he is doing today has passed the quality control tests and may be sent to the treating physician. Whether to allow the report to go out of the lab, one has to then follow Westgard rule. It is a set of rules which was devised by Dr. James Westgard in 1981. For more details, students are advised to consult textbooks of clinical biochemistry. ओके फ्रेंड्स, चैप्टर 11 कंप्लीट हो गया है। नेक्स्ट चैप्टर है 12 बायोलॉजिकल रेफरेंस इंटरवल। इसको नेक्स्ट वीडियो में कवर करेंगे। तब तक के लिए बाय। पढ़ते रहिए, मुस्कुराते रहिए। थैंक यू।